So what happens when a pipe breaks deep underground? We can't always just dig it up, right? The solution is pretty amazing. We fix it from the inside. But to make that work, you have to get one thing absolutely perfect, and that's pressure. So let's dive in and really unpack what that means. It seems like a pretty straightforward question. You've got this flexible liner, you slide it into the old pipe, you inflate it, and boom, you're done. So what's the magic number? How much pressure do you actually need? Well, as you might have guessed, the answer is a bit more complex, and honestly, a lot more interesting than just a single number. See, here's the thing. We're not just talking about one kind of pressure. It's actually a whole system of different pressures, each one doing a very specific job. And getting that system right, well, that's the difference between a perfect, long-lasting repair and a huge failure.
Okay, so to really get our heads around this, we've got to break it down into two totally different types of pressure. First, you've got the pressure you use to actually do the job. And then there's the pressure you use to prove the job was done right. Two completely different things. The easiest way to think about this is like this. The inflation pressure, that's the working pressure, that's the muscle, It's doing the heavy lifting, physically pressing that new liner against the old pipe while the resin cures. Then you have the test pressure. That's the inspector. It shows up after all the work is done to give it the final official stamp of approval. Yep, this is watertight. And look, none of this is just guesswork. It's not like someone just picks a number out of thin air. It's all governed by a super specific standard, the DIBZ 42.3-385. Now, don't worry about the name. Just think of it as the official rulebook for this kind of work. It spells out exactly how to do things to make sure every repair is safe, reliable, and, actually lasts. All right, so let's start with the easy one, the final inspection. This is the most straightforward part of the whole process. It's basically the final exam for the new pipe. Did we pass or fail? And here's the beautiful part. Unlike the working pressure we'll get to in a minute, this number is simple. It's fixed, it's totally non-negotiable. The test pressure is always 0.5 bar. That's it. It's the universal standard that says, yes, this liner is perfectly sealed. So, how does the test actually work? It's incredibly straightforward. First, you seal off the section of pipe that was just repaired. You fill it up with water, and you pressurize it to exactly 0.5 bar. Not 0.4, not 0.6, exactly 0.5. And then, you wait. The pressure has to hold steady without dropping at all for a full 30 minutes. If that little needle on the gauge hasn't budged after half an hour, bingo, the repair is a success. It's definitive proof that you've got a watertight seal. Okay, so that's the test. Now let's jump over to the other side of the equation, the working pressure. This is the pressure you're using during the installation, and this is where things get a whole lot more dynamic. Remember that official rulebook? Well, it states this part very, very clearly. This pressure isn't just some quick blast of air to pop the liner open. No, it has to be brought up to exactly the right level and then held there completely rock solid for the entire time it takes for that resin to cure and harden. We could be talking hours here, and if that pressure drops even a tiny bit, it could compromise the entire repair. And this brings us to the single most important difference between the two pressures. Remember how the test pressure was always 0.5 bar? Well, the working pressure, it changes with every single job. There's absolutely no one-size-fits-all number. So, if it's not a fixed number, what decides how much pressure you need? Well, the biggest factor, by far, is the size, the diameter of the pipe you're working on. Now, this is where it gets a little counterintuitive, so stay with me. For a smaller pipe, say a 100mm residential line, you actually need a higher pressure. We're talking something close to 2.5 bar. But for a huge 800mm main drain, the pressure you need is much lower, maybe only around 1.0 bar. So it's this inverse relationship. The bigger the pipe gets, the less pressure you need to firmly press that liner against the walls. Kind of like how a bicycle tire needs way more pressure than a giant truck tire, right? So to put this all into context, that German approval we talked about covers a huge range of pipe sizes. And across that whole range, from the small pipes to the big ones, the working pressures almost always fall somewhere between 1.0 and 2.5 bar. But, and this is the key to all of this, whatever exact pressure is used for a specific job, it has to be written down and recorded in the official construction report. It's not optional. It becomes part of the permanent record. Okay, so we've covered the working pressure, we've covered the test pressure. Let's pull it all together. What are the big takeaways here? First, and most importantly, it's never just one pressure. You've got the working pressure for the installation and the test pressure for verification.
Second, the working pressure is dynamic. It changes depending on the pipe's size. Bigger pipe, lower pressure. Third, the final test is standardized. It's always that 0.5 bar for 30 minutes, no exceptions. And finally, recording that pressure isn't just busy work, it's mandatory. It's all about accountability and quality control. The whole system is built on precision and proof.
It's pretty amazing when you think about it. All of this complex, super precise science is happening completely invisibly, right under our feet, just to keep our cities running smoothly. It really makes you wonder, doesn't it? What other invisible science, what other unseen engineering is quietly keeping your world running right this very second?